Hey, AP Computer Science, this is Mr. Roberts, and boy, a lot has happened in a little bit of time. The last time I recorded a video, we were basically writing pretty simple programs. Everything was in the main method, and now all of a sudden, because we've popped into the world of Karel, we are now looking at full-blown object-oriented programs. We are working on different versions of a robot called Karel. And you've already done two projects, right? One of them was get the paper and the other one was build the S. There's two more that I've decided to have you do with the quote-unquote advanced Karel model. A lot more tricks, a lot more features here. And I'm going to talk to you a little bit about that. This video is mostly about what we call method decomposition, right? I really want us to talk about how we decompose a bigger task into a series of smaller tasks. So if you've read the prompt for corn Karel, you know that Karel has to plant a bunch of corn. Let me compile this. Plant a bunch of corn in a field to help out a farmer. And there it is. And there's certain specs. Like I think as it goes up this way, it has to put one plant and then skip a space. One plant, skip a space. And as it goes over it this way, it has to skip 2 rows. Well, if you think about it, it's like I'm not going to sit here and tell Karel every little step it makes, and I don't really know how big the world necessarily will be. Right now, there's a fence here at the very top, and that fence would prevent Karel from going in, to the neighbor's farm and planting corn over there. But maybe, this farmer buys more property next door, and all of a sudden this fence is moved. Karel should be smart enough that it can figure out, oh, I'm in a bigger fenced yard now. I'm going to keep planting corn longer and longer until I can't. So let's take a look at this. I've said that I suggested some methods to help with decomposition. One of the things that you need to know is when you do actually ask Karel to run, what happens in the Greenfoot simulator is it basically, when I click run, it continues to call this act method again and again. It's a while loop, and as long as Karel is up and operational, it'll keep acting and acting and acting. Probably for our purposes, we would probably want to start out with creating a code right here. I'm just going to say right here, I'm going to tell Karel to turn off. Now, if you're wondering, how in the world do you know that you can ask Karel to turn off? I didn't, and I'm not going to print up all the commands that come with the advanced Karel, but I really encourage you to right-click Karel and take a look at it. You can see that there's methods that we can call on Karel. In fact, all of these methods, plant a row, return to start, set up next row, are ones that I've kind of specified right here. So you can see here's public void plant a row. The reason why when I right-click on Karel and I see that, it's because we said, oh, there's going to be a method called plant a row. Now, as it is right now, that method does absolutely nothing. But there's also a method called return to start, set up next row, and then of course there's act. So that's for this particular instance of it. But there are things that Karel has inherited from a superclass. So for example, you can see that our corn Karel extends something called robot. Corn Karel extends robot. And that means that basically all of these methods here, let me move this up a little bit higher so we can see all of them on the screen. All of these methods here, any beepers and beeper bag. Oh, it'll return true if there's beepers in the beeper bag. Boolean, facing east. So what happens if I run the command facing east, Karel will return true if facing east. Facing north, southwest. If the front is clear, that'll return a Boolean true. Yeah, the front is clear. If you are next to a beeper, and by that it means Karel is right over a beeper. It's on top of it. Not if there's a beeper, in front of it, to the left, to the right, but just right on top. And then also there's this other Boolean next to a robot. We haven't even begun to think about what the world would look like if there's 2 robots in the world simultaneously running, but Boolean next to a robot should be interesting to look at in the future. And then this the robot inherits a bunch of things from the UR robot, and the UR robot inherits things from the actor class. So I can look at all these different things. We've already seen some of them. String color. If I invoke that, it says currently this robot is yellow. I can also find out, let's see, I can say, well, what else can I do? Oh, from some of these I can say, is it facing east? No, actually I would consider this to be facing west, so it's going to say, and it did, it says false. Now if I asked it, is it facing, let's see, is it facing west? True, this robot's facing west. Now I can move it right here, and you can see now there's a wall right in front of it. So if I ask it, hey, front is clear, it's going to say false. Front is not clear. There's a wall right there. I can't go. So basically we're going to use these types of commands, and we're going to try and break up this bigger task into smaller pieces. I'm going to help you out with this one piece called plant a row, just so you can kind of get a flavor of some of the thinking that can go into designing a solution. And I just want to preface this by saying anything that I say or do it's my solution, and there's a ton of other ways that you could figure out a solution. There's a lot of different things, so don't feel stifled like it's, hey, that's just the one way, I've got to do it that way. There's tons of things that you can do that would work equally well, and probably, I know a lot of you, probably some of you would do better. So let's go ahead and start this here, plant a row. So first of all, I noticed that, Karel right now is not facing north. So if I'm going to plant this row, and it says Karel plants one row of corn from north to south. So it's just, well, or from south to north, but it's just straight up and down here. Well, in order for me to do that, Karel needs to be facing north, and I don't know that it necessarily is, right? I mean, I could ask it, hey, are you facing north? But really, it's more than me just asking it, are you facing north? I want it to face north. So I'm going to start with a command that will, I'm going to start with a couple lines of code that'll make sure it's facing north. And by the way, let me just say that these are what's, I'm speaking of what are known as preconditions, right? Right now, I'm not saying a precondition of planting a row is that it has to be facing north. I don't care which direction Karel is facing. I'm going to accept that, and I'm going to make it face north. So my precondition is Karel can face any direction it wants, but I think it needs to be at the bottom of the row. So if I was going to list my preconditions, and it's actually a really good thing to do, I would say Karel is at the bottom of a row to be planted. I would also say Karel can be facing any direction. So as long as those preconditions are met, if another method calls plant a row should be able to deal with those preconditions and make it work. So for example, Karel's at the bottom of a row. This would not be meeting the preconditions, right? Karel is not at the bottom of a row. Now I could extend this and make it, oh, you know what, Karel can be in any row it wants to be, and then what I could do is I could write the code to make sure Karel is at the bottom of the row, and then it faces north and then plants. But right now I'm just going to say, hey, my preconditions are Karel needs to be at the bottom and Karel can be facing any direction. But as long as those two things are true, I can plant a row of corn. So I'm going to start with a while loop, and this is a great place to use a while loop. So what I'm going to say is while, and what I want to use is not facing north. So if you recall, there was I hope I got that right. If you recall, let me try and compile that. If you recall, there was a command in Karel that's, and every single time it's just get used to it. Whenever I think if you shift and drag, yeah, that's quicker. You don't have to right click it and say new. If you just hold down the shift key and then drag it over, you can get that to go. But if you recall, one of the commands was, it was facing north, right? It returns a Boolean. So what I want to do is, while Karel is not facing north, a command I can use is turn left. So Karel is just going to kind of go around in a circle until it's facing north. Now I want to kind of test this out a little bit, so I'm going to come down here to my act method, because this is going to be the thing that I call, and I want to ask the act method to plant a row. I'm going to say plant row, and I'll compile that. So if I ask this method to plant the row, it's going to jump up here and run this code. So let's see what that looks like. Again, I got to compile it, and then I'm just going to go ahead and hold down the shift key and just shift drag one of these carols. Was that not the shift key? There it is. Shift and just click right there. So I'm going to go ahead and ask it to act and watch what it does. Do you see that? The thing turned around and it kept turning around. It says, while you're not facing north, keep turning left. Eventually, it's going to get to where I am now turning left, which is beautiful because now this thing is ready to start planting a row, right? And it could be over here getting ready to plant a row, over here anywhere, but it's ready to plant a row because it's facing the right direction. So let's see, now what we want to do. You know what, this is probably not going to be the best. Well, let's see. I know that eventually I'm going to hit this wall up at the top, and I don't want to hit the wall. So I could try something simple, like, let's just try this. I'm going to try put beeper, and I'm going to say move, oops, and then move. So let's give this a try. Let's just see what happens here. So because I know that's the right spacing, I need to move and not plant a beeper in every spot, but move twice and then plant another one. So let's go ahead and take a look at this. So it's all compiled up. We'll bring this out, and there it is. And I'm going to say act. Oh, well, that's not a good thing. It only did it once, right? Well, let's try this. Let's try this. While front is clear. That's always fun. Let's try this. While the front is clear, what we would like for you to do, Karel, is to put a beeper and then move. Now, I'm already ahead of you. I'm anticipating there's going to be an error here. By the way, auto layout, perfect, beautiful. By the way, auto layout is Control and Shift and I. That's a great trick. Okay, so let's go ahead and try this again. Let's compile that, and let's go ahead and bring one of these out. Okay, so let's try this. Yeah, nice. Except I just had a bad day here, and it's on a different screen because I'm using two different monitors. Let me bring this here. What just happened? You can see it's right here. It says the front is blocked. So I just had a bad moment in terms of the life of Karel, because this should not happen, right? Basically, Karel crashed. I didn't turn it off nicely. It crashed because it hit a wall when it shouldn't have run into the wall. It tried to go, but this wall is here, and it's a bad day. Anyways, what we can do is we can check for that, right? We can make sure that Karel doesn't have this problem. So I suggest a little bit different approach. And here's what I'm going to try. And again, this is one guy's solution. You could do different things. So I'm going to create a Boolean here called go, and I'm going to set it equal to true. So as long as go is true, I want it to do this business right here. So I'm just going to say while you're going, you're going to do this. Now, each one of these moves has the potential of causing Karel to crash into a wall. So I'm going to encapsulate them with a little if statement, right? So these if statements are going to be if front is clear, if front is clear, then I want to have our beautiful Karel move. Now I can't just say move. Oh, watch this. Control Shift I. Love it. I can't have Karel just go move, because it could be the front is clear for one move, but if I do move, it'll crash on the second time. So I'm going to put each of these in their own if statement. So I'm going to say again, if front is clear. Oops. And what are we going to do? We're going to ask it to move a second time. Oops. And Control-Shift-I. So if front is clear, move, move. Now, I'm just going to throw this down as a separate thing. So take a look at it. Okay, I'm doing a little bit of white space. The first one, I place the beeper, and then I'm moving twice. So to me, that's kind of two separate things. So I got a blank line in between there. Place the beeper, move if you can, move if you can. Now, if at either one of those points the front is not clear, right, we would know that it would ignore one of those moves. I'm going to use this fact that the front may not be clear in order to tell Karel to stop doing this, put beeper, move, move. So what I'm just going to say is, hey, another if statement. If it is not the case, if front is clear, is not true, if that's not true, then in that case, Karel, what I would like for you to do is I would like you to set go to false. And close that. Aha. So put beeper, move, move. If the front isn't clear, trigger go to false so that it'll stop doing this loop. Let's give this a try. So, oops, TRUE needs a semi. Oops, not there. We need a semicolon right here. Any other weird compiling things? Oops, I spelled Boolean wrong. B-L-E-A-N. Boolean. And of course I misspelled true. That's great. So true is T-R-U-E, not T-U. And by the way, I love this. They turn blue, so you can just look at the color and know. Okay, class compile, no syntax errors. Thank you. Let's go ahead and bring one of these out. So hold the shift down. And let's ask it to act. That is great. The only thing I'm going to ask Karel to do is I'm going to have it do one more thing before I end this method. I'm going to have it just print something out to the terminal window. So I'm just going to add a line of code right here after the while statement. And I'm going to say, yeah, this is just me because I just want to make sure that it didn't crash. And in fact, when this program is finished, I will probably remove this. I don't think this is a great idea, but I just want to make sure this terminal window pops up. So again, I'm just going to come over here and hold down Shift. I have Corn Karel selected. You see I can pick other one. But with this one selected, I'm just going to hold down Shift and click. By the way, it doesn't matter. You can see it doesn't matter where you click because this is set up to put it in a certain spot. But let's go ahead and ask it to act. 3, 4, 5, 6. Finish planting row. Now here's the thing that, let me see, option, let me clear all this. Let me have it run it one more time. Yeah, finish planting row. Excellent. Excellent. It did not crash at all. It finished planting the row, and it's good to go. Let's see what else could happen here. I could move Karel around. Yeah, I think it's one part of a solution. Now you can think about the other part. Like after Karel is up here and it's planted a row, probably a good thing to do is make it to, turn around, and while front is clear, just keep stepping, stepping, stepping. And then once you're down, you're down at the bottom of the row, you can say turn left, and then you could do move, move, move. And then at that point, you're now in a location where you can call this plant row again, and you're set up to go with this row again. Anyways, I hope this helps you think about what I mean by method decomposition. We're taking a bigger task and we're breaking it down into a few smaller parts. I don't know that the names of these makes the best sense. I like plant row, but I'm looking at this return to start. I might name that to return, set up next row. That might be this might make it go down to the bottom and get over so that it's in the right spot to begin the next row. I don't know what return to start is going to do. Maybe, does that mean where it started planting the corn? Back to the barn? I don't know. Anyways, I hope this helps you get started, and please talk to me, have fun. This is fun. Karel's fun. Coding's fun. This is Mr. Roberts. Goodbye.